Hello and welcome to Code and Magic channel. In last tutorial, we learned how we can set up OpenGL with GLFW and GLAD. And this tutorial, we're going to learn how we can create a window with GLFW and explain line by line what's happening. So the first step is to include the GLFW header file, which is include glfw.h, and this line includes the necessary header file for glfw, which provides the declarations for glfw functions and types. Then we need a main function which returns 0. Return 0 means success. The next step is to initialize the initializing the glfw library, and if we call the glfw init, it will initialize the glfw, but this function returns true or false, which means if it wasn't successful it will return false, otherwise it will return true. So we can check if it wasn't successful. If it returns false, then you can return -1. So the next step is creating a window using glfw. The function glfw create window, if we going to call this function, we can see that it will return a glfw window pointer, and it gets width, height, title, monitor, and share. These last two parameters are optional, but we can pass the other ones. And we can store its value to glfw window pointer, and we call it window. And for passing parameters, we can pass, for the width we can say 640, for the 480, and for the title we can say hello world. And because these last two parameters are optional, we pass null, so we have a specific window here. And you can see here in the description the handle of created window, it returns the handle of the created window or null if an error occurred. So we can check here, if not window means if it couldn't create the window, you can return -1. And before that we have to call the glfw terminate, and this function basically frees any resources allocated by glfw. Well, now we have created the window, and the next step is to making this window the current context, which is glfw make context current, and it gets a window. So this function is important, and you may ask what it means to make context current. Well, making the window's context current is an essential step when working with OpenGL. It establishes a connection between the current window and OpenGL rendering context. In OpenGL, a rendering context is a state machine that stores all necessary information and resources required for rendering graphics. This includes things like shaders, textures, buffers, and other OpenGL functions. And this line makes the context current, and it means that when you issue rendering commands, OpenGL modifies the state of the current context. And by making the current context, for a specific window, you ensure that the rendering commands will affect the window that you just created. And well, and once the context is made current, you can issue rendering commands such as clearing the color buffer, drawing primitives, applying transformations and setting up shaders and textures, this command will affect the specific window that we just created. So it's very necessary to call this function. Then, okay, after this is we need to have a render loop, which is basically a while loop. We can create a while true, which runs forever, but it's better to check if this window is still open. So we can check if it's not open. Until it is open, you keep running. If glfw window, the function is glfw window should close, and we pass window. It checks if window shouldn't close, so keep the while loop. Otherwise, go outside of the while loop. And outside of the while loop, we can terminate the glfw and free resources that glfw is taking. But in the while loop, we need to do specific things. The first thing that we need to do is gl clear. And here we pass gl clear color buffer bits. Color buffer bits. And you may ask, what does it mean? What does it mean to clear color buffer bits? Well, this command is used to clear the color buffer of the current OpenGL rendering context. It is an essential step before rendering a new frame or scene. And in OpenGL, the frame buffer is an area of memory that holds the color, depths, stencil information for rendering target. The color buffer is a component of the frame buffer that stores the final color values for each pixel on the screen. And the color buffer is a 2D dimensional array of pixels that represents the image displayed on the screen. Each pixel contains color information such as RGB or RGBA. And before rendering a new frame, like every frame actually happens in every time the while loop run. And before rendering a new frame, it is a common practice to clear the contents of the color buffer to prepare a blank canvas. So this command is used to achieve this. And so maybe you may ask why do we clear the color buffer? Well, clearing the color buffer is necessary to ensure that the window is blank and ready for rendering the next frame. Actually, without clearing, the previous frame content would persist and leading to unwanted artifacts or visual consistencies, and you may get effects like this that you may remember from Windows XP. So if you don't clear the context, it will you don't clear the frame buffer of the color, this thing may happen. So well, this is the clear color. The next thing that we need is to glfw swap buffers, and we pass the window. And this one is also another important thing that we need to write. And it's actually, in most cases, OpenGL applications use double buffering. So this means that there are two color buffers. Let's explain it here. There are two color buffers, for example, here and here. Which one? One of them is the front buffer and the other one is back buffer. So the front buffer is the buffer that will be displayed on screen. And the back buffer is where the rendering process happens. So when we doing the rendering, when we say that do this, do that, draw this, and all of these things happen here, and when the rendering is finished, the back buffer and front buffer will be swapped. Like the back buffer becomes the front and the front becomes back. And this is what this command is trying to do. And why we do this? Because you're not going to show, like when you're rendering, when you're doing the processing, you cannot do it in front buffer because the users can see this. Like, for example, when you're rendering a heavy scene or a heavy picture, you may see the visual artifacts and like issues in rendering, but when it happens in behind the scene and it's in a back buffer, the end user won't see it. And when it is ready, it will be swapped and end users will see the final picture. So it's very important. And the final things that we need is glfw poll events. And this is basically process any pending events such as window resize events or keyboard or mouse input. This allows the program to respond to user interactions. So now if I run the program, I will see a window here. And if I close it, we'll see the exited with code 0, which means it will run successfully. Well, this was the explanation of line by line. That is what's happening. In the next tutorial, we will expand this code and we'll add other lines and explain it again to make it ready for creating your first triangle. Well, thank you for listening, and if you have any question or issue, make sure to write it down in the comment section. And if you like this video, make sure to hit the like and subscribe. And thank you for watching.